The universe may look endless, but its true shape is not a matter of guesswork, it is written into the physics of space itself. Measurements of ancient light, galaxy distributions, and cosmic expansion all point toward a precise geometric answer. Within the first 10 seconds of this video, here is the critical takeaway. Modern observations strongly suggest the universe is spatially flat, yet that does not automatically mean it is infinite. Understanding why requires unpacking one of the deepest questions in cosmology. Why the shape of the universe matters. When scientists talk about the shape of the universe, they are not referring to its visual appearance or outer boundary. Instead, they mean the geometry of space on the largest possible scale, how parallel lines behave, how triangles add up, and how light travels across billions of light years. This geometry determines whether the universe will expand forever, eventually collapse, or coast endlessly at a steady pace. It also decides whether space wraps around itself or stretches on without limit. Cosmology recognizes three primary geometric possibilities: flat, positively curved, and negatively curved. Flat universe, the leading model. A flat universe follows the rules of Euclidean geometry. Parallel lines never meet, the angles of a triangle add up to exactly 180 degrees, and space behaves as most people intuitively expect. Observational evidence overwhelmingly supports this model. Measurements of the cosmic microwave background, the afterglow of the Big Bang, show that large-scale fluctuations in temperature align almost perfectly with flat geometry. Data from missions such as Planck satellite reveal that the universe's total energy density is extremely close to a critical value that predicts flatness. However, flat does not mean simple. A flat universe can be either infinite or finite, depending on its topology. Space could loop back on itself in subtle ways, meaning you could theoretically travel far enough in one direction and return to your starting point without ever encountering an edge. Positively curved universe, closed but finite. In a positively curved universe, space resembles the surface of a sphere, but in 3 dimensions. Parallel lines eventually meet, and the angles of a triangle add up to more than 180 degrees. Such a universe would be finite but unbounded, meaning it has a total volume but no edges. If you traveled far enough in a straight line, you would eventually return to where you began. Early cosmological models favored this possibility, especially those predicting a future Big Crunch. However, current observational data show no detectable positive curvature at the scales we can measure. If such curvature exists, it is far smaller than what today's instruments can detect. Negatively curved universe, open and infinite. A negatively curved universe behaves like a saddle shape. Parallel lines diverge, triangle angles sum to less than 180 degrees, and space expands more rapidly than in the flat case. This geometry implies an infinite universe with no wrapping or closure. While mathematically elegant, this model is increasingly inconsistent with high-precision observations of the cosmic microwave background and galaxy clustering. Modern data place extremely tight limits on negative curvature, making it an unlikely description of reality. Is the universe infinite? Here is where assumptions often fail. Flatness does not automatically imply infinity. The observable universe is finite because light has traveled for a limited time since the Big Bang. Beyond that observable horizon, space may continue infinitely, or it may curve or connect in ways we cannot yet detect. Cosmologists distinguish between observable size, what we can measure; global size, the universe's full extent, which may be unknowable. Inflation theory suggests that if the universe is flat, it is likely vastly larger than what we can observe, possibly infinite in practice, even if finite in principle. What science can say right now? Based on current evidence, the universe is very close to flat. Large positive or negative curvature is ruled out. Whether space is infinite remains an open question. No physical edge of the universe has ever been observed or predicted by mainstream physics. Future missions and deeper surveys may refine these conclusions, but some aspects, especially global topology, may remain beyond experimental reach. The bigger picture. The shape of the universe is not a philosophical curiosity. It determines how space, time, matter, and destiny itself are connected. Flat geometry explains why the universe looks the way it does today, while leaving open profound questions about what lies beyond our cosmic horizon. Understanding this geometry is one of humanity's most ambitious scientific achievements, and one of its most humbling. If you want to explore more mind-bending questions about space, time, and the structure of reality, subscribe and continue the journey. The universe is revealing its secrets, one measurement at a time.